schedule get-go. That early completion schedule needs to be justified. It needs to be proven that it's possible for the contractor to actually achieve an early completion time. The contractor must show that it has the resources to achieve this early completion time, not only on the early start times, but on the late start times as well. Number three, the contractor must take into account realistic resource constraint scheduling. If the project involves critical and limited supply resources, those resources that are in limited supply and they are make or break resources for the project must be taken into consideration during the scheduling of the activities. Number four, just like the baseline needed to be realistic and reasonable, number four, the schedule needs to be updated regularly, and those updates need to be reasonable, meaning they need to capture correct percent completes, correct actual starts, correct actual finishes, remaining duration for the activities that are in progress, and ideally would be good to capture the actual logical relationships among the activities. And number five, it's very important for contractors to realize that during any claim that is prepared for a time extension, that claim is going to be subjected to cross-examination by the opposing party, which means that during that cross-examination, the other party is going to be looking for potential errors in the baseline schedule, potential errors in the updates. Sometimes those errors are intentional, sometimes they are not. What's important here is that we, as contractors, as number five indicates, should do what we have to do to not manipulate the schedule, to not induce errors, to not force errors into the schedule that will come back later and work against the claim for a time extension. There are, in general, there are four methodologies for delay analysis, and each of these four methodologies has different flavors. So altogether, we may have 2 or 3 flavors for each of the four methodologies, and so potentially you may have up to anywhere from 15 to 20 different combinations and possibilities to perform the delay analysis. But the four major categories are this. First, we have the as-planned methodology, where we basically incorporate delaying events into the as-planned. And this technique was developed a long time ago to basically assess the question of what's the owner's liability for the delays. And we're going to use the as-planned to take the owner's delays into insert those delays into the as-planned, and then forecast the project completion time. This methodology, as the name implies, ignores the as-built conditions, and of course that's a significant weakness of the methodology. But it's beautiful. It's beautiful in the sense that we have a reasonable as-plan, and we can insert, we can add delays, particularly the owner-responsible delays, and forecast what would have been the impact of these delays had we known about these delays at notice to proceed. Then we have the as-built methodology. Of course, this methodology assumes that the project is finished. It's a retrospective methodology. We basically will look at the as-built critical path and find out what delays landed on the as-built critical path, and then apportion responsibility for those delays based on what delays are actually on the as-built critical path. This technique requires, of course, that as we perform the updates on the project schedule, month by month, week by week, when we end with the project, that we will have an as-built critical path. Without it, we will have to recreate it. And of course, it is quite difficult to recreate history if that history was not recorded contemporaneously. But it is possible, indeed, to recreate a critical path after the fact. Of course, a great deal of justification will need to be required to justify why the critical path is what it is if it was recreated, because it is possible that multiple possibilities could be created to recreate the critical path, and the chosen one will have to be justified. Number 3 is the contemporaneous method, and that is the delays are analyzed as they occur. So we draw a data date, we look at the delays that occur in that period of time, and then we forecast the project completion date to the right of the data date. So to the left of the data date, we will have the as-built to that point, including delays, and then to the right of the data date, we'll have the remaining activities to be completed, potentially including some resequencing if necessary, and then forecast the project completion time and assess what's the impact of the delays to the left of the data date. And then we have the collapse as built, also known as the but-for, where we basically are going to assess the impact of delays by subtracting those from the as-built schedule. Because we're subtracting these delays, it implies that it is a retrospective methodology as well. And so here you have 4 major classifications of methodologies. As I mentioned before, each of these is going to have multiple flavors, multiple ways of implementing it. And that yields different variations in the implementation. In this webinar, I'm going to give you a more detailed analysis and examples of these 2 methodologies, the as-built method and the contemporaneous method. Michael, I think we're ready for the next poll questions. Can you go ahead and pose those 2 additional poll questions?
Absolutely. Our next question: do all delays on a construction project lead to an extension of time? Go ahead and take a minute. Give us an answer, your best guess. It's a tough question, that one. That's great. Thank you. We got almost 90% votes are in, and if I close that, the results say this: do all delays on a construction project lead to an extension of time? We had 1% voted yes, we had 95% vote no, and we had 4% vote I'm not sure. So tell us, Jesus, what's the answer to that one?
Well, I think we have a great class with us because 95% of the people are correct, in the sense that delays, just because a delay occurred, doesn't necessarily mean that there will be a time extension. And the reason is that for a delay to extend the project completion time, that delay must have one important attribute. That delay must be critical. That delay must be in the critical path. And that means that there could be other delays that land on non-critical paths, which means that the effect of the delay, the impact of the delay, is going to be absorbed by the float within that path. So 95% of those here are correct, and I'm so glad to hear that, because you're absolutely right. Just because we have a delay doesn't mean we're going to have an impact on the project completion time. Let's do the next poll question.